Hey everyone! The first question for this day is question number 22 of the chapter Some Basic Concepts of Chemistry. And the question says, if the speed of light is 3.0 into 10 power 8 meter per second, calculate the distance covered by light in 2.00 nanosecond. So this is a very easy question. We know that speed is equal to distance by time. Here in this question, we are asked to calculate the distance. So we can rewrite this equation as distance is equal to speed into time. Now, let us put the values. Here we have speed as 3 into 10 power 8 meter per second and time as 2 nanosecond. We know that time is given in nanosecond, whereas the speed is given in seconds. So we are trying to convert this nanosecond to second. For this, we know that 1 second is equal to 10 power 9 nanosecond. We have to convert nanoseconds into seconds. So let us see how much 1 nanosecond is. We know that it is 1 by 10 power 9 second, or 10 power minus 9 seconds is equal to 1 nanosecond. Now we have to convert this 2 nanosecond into second. What do we do? For this, we multiply this 2 into 10 power minus 9. So we converted this nanosecond to second. Now let us put these values in this equation. So we get distance is equal to speed 3 into 10 power 8 meter per second into time, which we have converted into second. We get 2 into 10 power minus 9 seconds. Solving this, 3 into 2 is 6 into 10 power 8 into 10 power minus 9 gives us 10 power minus 1 meter. So this is the distance covered by the light in 2.0 nanosecond with the speed 3 into 10 power 8 meter per second. Let's move ahead with the next question. Question number 23 says, in a reaction A plus B2 gives AB2, identify the limiting reagent if any in the following reaction mixture. And then we are given 5 samples. So here we are dealing with the concept of limiting reagent. To identify the limiting reagent, let us first write down the data that is given to us. So in the first sample, we are given 300 atoms of A and 200 molecules of B. When we look at this equation, we can say we are having 300 atoms of A, 300 molecules of B as well. But here we are only given 200 molecules of B. So we can say the reactant B is limiting, and therefore this will be the limiting reagent. Similarly, if we look at the next sample where we are given 2 moles of A and 3 moles of B. Again, we know that equal amounts of reactants are required to form this product. Here, when we have 2 moles of A, we are only in need of 2 moles of B. But here we have 3 moles of B. That means the reactant B is in excess and the reactant A is limiting. So, according to the second sample, reactant A is the limiting reagent. In the third sample, we are given 100 atoms of A and 100 molecules of B. It is very clear that equal amounts of A and B are reacting here. So there is no limiting or excess reagent in this. And in the fourth sample, we are given 5 moles of A and 2.5 moles of B. As I have mentioned earlier, when we have 5 moles of A, we will be in need of 5 moles of B. But here we have only 2.5 moles of B. So we can say the reactant B is limiting here, and the reactant A is excess. And in the last sample, we are provided with 2.5 moles of A and 5 moles of B. Here we can say when we have 2.5 moles of A, we are only in need of 2.5 moles of B. But here we are given 5 moles of B. So we can say that the reactant B is in excess and the reactant A is limiting. So this question can be very easily solved if we try fixing one of the reactant and talk in terms of the other by looking at the balanced equation. I hope this question is clear. Let's move ahead with the next question. Question number 24 says, dinitrogen and dihydrogen react with each other to produce ammonia according to the following chemical equation. And we have the chemical equation N2 plus H2 giving us 2NH3. And then there is a series of 3 questions where the first question says, calculate the mass of ammonia produced if 2.00 into 10 power 3 gram dinitrogen reacts with 1.0 into 10 power 3 gram dihydrogen. Second question says, will any of the two reactants remain unreacted? And the third question says, if yes, which one and what would be its mass? So let us try doing the first part of this question. From the question, we have the chemical equation as N2 reacting with H2 giving us 2NH3. Now, this is not a balanced chemical equation. Let us balance this equation first. We know that to balance this equation, there should be 3 atoms of hydrogen so that there is equal number of atoms of hydrogen on both sides of the reaction. That is the reactant and the product side. So now we have a balanced chemical equation. Now we have the given data, that is we are given 2.00 into 10 power 3 gram of dinitrogen and 1.00 into 10 power 3 gram of dihydrogen. So this is the given data for us. Now let us look at this equation. We know that here 1 mole of dinitrogen is reacting with 3 moles of dihydrogen to give us 2 moles of ammonia. With this given data, let us try calculating the number of moles. We know that to calculate the number of moles, we have an equation which says number of moles is equal to given mass upon the molecular mass. So this is the equation that we are following to calculate the number of moles. The number of moles of dinitrogen can be calculated as, we have the given mass as 2.00 into 10 power 3 gram divided by, we know that the molecular mass of dinitrogen is 28 gram. Solving this, we get 71.43 moles of dinitrogen. Similarly, we can calculate the number of moles of dihydrogen as 1.00 into 10 power 3 divided by 2, which gives us 500 moles. From the balanced chemical equation, we can say that here 1 mole of dinitrogen is reacting with 3 moles of dihydrogen to give us 2 moles of ammonia. Now we have to calculate how many moles of ammonia will be produced when 71.43 moles of nitrogen is reacted. So this is what we have to calculate first. And we know that for 1 mole of dinitrogen, we are having 2 moles of ammonia. To get this answer, let us do the cross multiplication. So we get 71.43 into 2 divided by 1, which gives us 142.86 moles of ammonia. In the question, we are asked to calculate the mass of ammonia. So, in order to calculate the mass of ammonia, we can say mass of ammonia is equal to number of moles of ammonia into molecular mass. So for this, let us first calculate what the molecular mass of ammonia is. So we know that the atomic mass of nitrogen is 14 plus 3 into atomic mass of hydrogen, that is 1, which gives us a total of 17. So 17 is the molecular mass of ammonia. Now let us find the mass of ammonia. For this, we already know that we have calculated the number of moles of ammonia to be 142.86. And then we have calculated the molecular mass as 17. So multiplying this, we get 2428.62 gram of ammonia. So we have calculated the mass of ammonia, and this is the solution for the first part. Now let us look at the second part. In the second part of this question, we are asked if any of the reactant is unremained. For this, let us look at this balanced chemical equation where N2 is reacting with 3H2 to give us 2NH3. We have already calculated the number of moles of nitrogen to be 71.43 and hydrogen to be 500. Now, we know that according to the concept of limiting reactant, when 71.43 moles of nitrogen is being used, it requires 71.43 into 3 times of hydrogen. Solving this, we get 214.29 moles. That is, when 71.43 moles of nitrogen is reacting, it requires 214.29 moles of hydrogen. But we have 500 moles of hydrogen. So we can say the hydrogen is in excess. So we can say some amount of hydrogen remains unreacted because it is in excess amount. In the third part, we are asked to calculate the mass of this unreacted hydrogen. For this, let us first calculate the amount of moles of hydrogen that is unreacted. For this, we know we are provided with 500 moles of dihydrogen and we required only 214.29 moles of hydrogen. So to find the amount that is unreacted, all we have to do is subtract this 214.29 from this 500. So we get the amount of unreacted hydrogen, that is 285.71 moles. Now to calculate the mass, similarly as done before, we have to multiply it with its molecular mass. We already have the number of moles, so we have to multiply with the molecular mass. So let us find the mass, that is equal to the number of moles, that is 285.71 into molecular mass of hydrogen. Here it is 2, which gives us 571.42 gram. So this is the amount of hydrogen that remains unreacted. Question number 25 says, how are 0.50 mole Na2CO3 and 0.50 molar Na2CO3 different? So this is a question which checks our understanding about mole and molar. We know that when we are talking about mole, we are mentioning the quantity, and when we are talking about molar, we are mentioning the concentration. So here we have 0.50 mole of Na2CO3. Let us first calculate the molecular mass of Na2CO3. For this we know the atomic mass of sodium is 23 into 2 because there are 2 atoms of sodium, plus atomic mass of carbon is 12 plus 3 into atomic mass of oxygen, that is 60. And this gives us 106 gram. So this is the molecular mass of sodium carbonate, that is Na2CO3. Now 0.50 moles of sodium carbonate gives us 0.50 into this molecular mass 106 gram, that is equal to 53 gram of sodium carbonate. So this is a quantity. Now we have 0.50 molar Na2CO3. This means we have 0.50 moles of Na2CO3 in a solution of 1 liter, and we have already calculated that this 0.50 mole is equal to 53 gram. So we have 53 gram of Na2CO3 in 1 liter of solution. So this is what 0.50 molar Na2CO3 means.